What's going on, guys? It's the Unhinged Engineer, and today I have a very special episode of my grad school vlog. So if this is your first one with us, welcome. I am vlogging my graduate school journey as I get a master's in computer science at night through Georgia Tech's online program while I continue to work full-time. And today, it's going to be a little bit different from my normal vlog episodes. Normally, I'm just kind of speaking off the cuff about what I've been up to, what we're learning, things that are stressing me out, whatever's going on in school at that very moment. But today, we're going to be doing a formal review of the first class I took as part of the program, which is called Robotics AI Techniques. It's CS 7638. It's the first one I took. Overall, I'll give it a bit early. I really liked this class. I thought it served its purpose really well. It was highly recommended online as a great first class to take, and I think that ultimately held true for two main reasons. First of all, the workload was super manageable, and yeah, it just didn't stress me out. It kind of gave me a good way to ease back into school and now juggling it with work at the same time. It was just solid in terms of being introduced to what life is like as part of this program. And then second point is I thought it was really well run. It's one of the oldest classes as far as I can tell, and it shows. It's pretty well organized. Everything follows a nice progression, and by the end of it, I feel like you have really strong foundations in this specific area of autonomy, effectively. I think they should change the name to autonomy, but it's whatever. The first half of the video is just kind of going to be talking about each of the topics we did briefly. I have videos on pretty much every project that I had to do as part of this, which went into technical aspects in more depth. But yeah, today I'll just kind of overview what this class is about from the content side, and then I'll get into my actual review of it, the good, the bad, and the ugly, mainly as a way to kind of hopefully inform kids who are going into the course not knowing what's going on like I did, as well as hopefully if any of the instructors wind up watching this, giving recommendations on how the class could improve. But yeah, overall, really liked it and excited to talk about it today. So let's get right into the content, which I think was the best part. So, robotics AI techniques. It's funny, the professor kind of mentioned in the beginning that it's a little bit of a misnomer. I think a lot of these things at the time, because the OMSCS program is pretty old. It's like, I believe it's over a decade old, if I remember correctly. But in any case, these things were once considered AI. Like, for example, in the search topic, we talked about Dijkstra's algorithm and A-star. I think today we would just call those like pathfinding algorithms, but the nomenclature around AI has shifted to mostly being about deep learning, like neural networks. So these, I would call it robotics techniques or like something else, right? Or autonomy techniques rather than AI techniques in robotics. But you can probably see that just from these topics I have listed here. So we start off with what's just called localization in the course. I'm referring to it as Bayesian localization, where effectively like you're in some unknown environment, you're in a known environment. So you have a map of what the space you're operating within is like, but you don't know where you are. And by taking measurements and then recording your own movement, you slowly collapse that probability distribution from something uniform, like where you have you could be anywhere and you have no more or less likely position to be in. You can collapse that down into one that is centered around your actual position, have a good reliable estimate of where you are. So super basic state estimation there, just basic Bayesian probabilities and statistics. From there, we use those building blocks to get into Kalman filters, which Kalman filters are kind of an intelligent way of weighing your measurements against your motion model with noise knowledge about both. So like you have an understanding of how much a measurement is noisy compared to a motion. And so you're slowly tuning that because those different confidence levels can change over the course of the run of your simulation or ultimately in the real world, right? So like if you are using cameras as your sensors and things get really dark, your measurements might get more noisy. Or if you're operating on rough terrain, your motion model might get more noisy, right? Or just less accurate. And so the Kalman filter is a filter that learns to filter out that noise in the system and ultimately, again, estimate where you are. After that, we get into particle filters, which are trying to achieve the same thing, but take a different approach. Where now, oh my God, I just realized I'm missing a topic, but I'll get back to that in a second. Now we're, instead of trying to get a unimodal distribution about our own position, we're spawning in a bunch of particles. We're using the same motion model for each, so we're having them all move in the same way. But at each step, we're resampling those particles based on how likely the position they're in is, given the measurement that we actually got from ourselves, right? So even though we don't know where we are able to take measurements and we can fit a Gaussian around that measurement and then measure or calculate how likely a certain particle position is given the measurement that we got. And so most of those will be very unlikely, and then we filter it down, we resample over and over again until we converge on where we are. After that, we got into search algorithms, right? So there it was mostly like Dijkstra's algorithm, A-star, value iteration, and other dynamic programming stuff. Basically just, you're in position A and you're trying to move to position B, and you're trying to find like the shortest path to get from A to B, or if you're generating a policy, like in something like value iteration, you're trying to find the best possible action for any position on the map. So this is pretty standard like computer science stuff, and I'll get into the projects that we did for that in a moment. I realized I'm missing something here. My bad there. I knew I was gonna forget something. After search, we talked about PID control. If you've worked in control systems like I have before, PID is kind of like the go-to starter control system that you learn. And effectively, that's just where we have some system that's in a current state, and we're trying to drive that system to a desired state. And we're bounding our control input based on how much error there is, the rate of change of the error, and the accumulated error, right? So that's the P proportional, D derivative, and I integral terms of that controller. This is something I've done a million times before. I've made a video about it, and it was just cool to do it another time. And then lastly, SLAM. SLAM is an acronym. It stands for Simultaneous Localization and Mapping. And so this is actually very similar to these original localization problems. The only difference is we no longer have a map that we're working with, right? So here we knew where everything else is, we just don't know where we are. But now we're trying to both figure out where we are on the map as well as draw that map, like estimate where landmarks are at the same time. And obviously this is a very active area of research in robotics and aerospace and different things. And so I would say overall, SLAM and Kalman filters were the two topics that really, really made me want to take this class. Mainly because Kalman filters I know is something super, super fundamental that I've actually worked with before, but I've never taken in a formal class setting. And SLAM, by contrast, is something really new and really cool that I've never gotten to do in either, like in a classroom or on an actual project that I've been part of. So these are the two topics that I was the most interested in, whereas localization is kind of just basic statistics stuff, which I didn't really think about going into the course, but obviously is really, really important for everything else we do. Search algorithms are something I've worked with a ton, as is PID control, so honestly I didn't really care going into those, but there were some new things that they taught me, and I have reviews of those experiences as well. And then particle filters, I hadn't really done anything with particle filters before. I'd done a little bit of particle swarm optimization for like trajectories, like orbital trajectories, but nothing specifically with state estimation through particle filters. And it was actually really fun. Like I would say, other than SLAM, this is probably my favorite project. And it was super cool, right? So this is a good segue now. Let me get into the projects and the assignments that we hit. So for each of these, right, for the most part, it wasn't a direct correlation, but it was pretty close. We had a problem set and a project. And then in the middle and at the end, we had exams, so midterm and final. So overall, I'll write out the grade distributions here. Problem sets were 18 total. That's divided between about 6, I believe. Projects, those were, let me think, I gotta do some math and apply now. So 13 each on average, right? Because the search project was actually weighted as more and the PID control project was weighted as less. So 13 times 5, we're gonna look like an idiot here. That would be 65, right? Yeah, 65. Localization didn't actually have a project, it was just these. So that's 65%. I hope, we'll see in a second. And then exams, 20% total. So that is, a midterm, which was worth 8%, and a final, which was worth 12, right? This sums to about 100. I'm gonna leave it there for the bit, but this is roughly the distribution of things. The main point I'm trying to get out here is that it was mostly weighted on projects. And I think that is a very, very good decision on the professor instructor's account, right? So that's what we had to do. There were also other things like extra credit, like there were some hardware challenges and research challenges we could do that were like pretty trivial. They taught me a little bit, but I was kind of just trying to bang out extra credit and get more points. But yeah, that's basically the content of the course that we went through. I think if you're trying to get into autonomy, guidance, navigation, and control, whatever, robotics, obviously, these are really good foundations, right? right? Because they all relate to each other really well. There's a very logical progression between them all. And that's actually going to be the first thing I'll talk about in my review of the course, right? So now we're going to transition here. What do I think was the best part of this course, right? For one, I think the topics, and I'll call it progression, right? I really think like the way they lay this out makes a lot of sense from a storytelling perspective. Like these are solid foundations from which you can build a lot of autonomous systems. And I think that the way they transition from one to another is really smart, as are the ways they segue with projects, right? Which I'll get to in a moment. But yeah, I really like just the material I think was great. Simple enough. I mean, this is actually the specialization I chose. So obviously I'm biased. Like I'm very, very interested in this stuff. But as someone who has worked on autonomous platforms and robots before, I can really confidently say that these are all relevant things that I can 100% see myself using in the future. And some of them I have used in the past. So really, really good topic selection there. Serves that really well. From there, I want to talk about the projects. I thought the projects in this class were fantastic, right? It was just really, really cool to be forced to implement these algorithms from scratch. They were organized really well, and it was just a great way to teach you. And I have these projects like on my portfolio now. As part of the Georgia Tech program, we can't share our code because obviously people can copy it and dump it in there. But I do have like the visualizations, a little bit write-up of what I learned and stuff on my portfolio. It's honestly like this class is just project farming, which is really fantastic, and I think it's just immediate value that it gives you going forward into other classes and other jobs. So I really, really like the projects. There was one of these that was kind of a sore spot. If you've been watching the vlog, you know which one it is, but I'll leave that out for now as a little cliffhanger. One of these I didn't really enjoy, but for the most part, I thought the projects were like the best part of the class by far, and that's reflected in the grade. And then after that, I'll talk about the instructors and students. So the lectures are very, very old, which we'll get to, but the instructors, like there are still instructors there that are doing office hours and live kind of like extra tutorials to walk through the projects and prep for the exams and stuff. I thought the people running the course did a really, really great job. They were super active on edX, which is kind of like the discussion platform. That's the official discussion platform. And yeah, they did a great job. They supplemented the lectures in really strongly, which I appreciated. They were really responsive with questions. And so I was a little anxious going in as my first like online course since like 2020, right? When everybody was doing school online, but they did a really great job for sure. The instructors were great. Also, the students were great. So aside from the edX discussion board, there was also like a Discord server that everybody joined. And there were lots of unofficial discussions there. People were really, really helpful without like cheating in any way. People would answer questions and kind of like, you know, put up like visualizations and say like, what do you guys think is going wrong? What could I add? What should I remove? Stuff like that. People were talking about other classes. Like, there was a lot of active discussion. And so I thought the Discord server was pretty cool. And I'm definitely going to be joining those unofficial discussion, you know, spaces, areas, whatever, as I continue in the program. So overall, yeah, I think the content was great. The projects that stressed the content was great. And the instructors and students that I was working with were all great. So like I said in the beginning of the video, overall, I rate this course really highly. But these are kind of the main reasons why. Now I'm going to get into kind of some things I thought could have been done better. And then one thing I think is kind of like a major flaw of the class. But again, overall, to kind of get negative for the next couple minutes, and then we'll circle back around to positive at the end. I really enjoyed this course, and these are the main reasons why. Okay, now let's get into the ugly stuff. So what could be improved about it? Well, for one, I thought the exams were kind of lame. I don't really, let's leave it at exams. I don't really see the point. I feel like these projects were fantastic and really force you to implement things such that you learn them at a fundamental level as you go in this very experiential way. And so I learned it, like I would go there and I would learn Kalman filters. I'd be like, oh my God, I built one from scratch. I really understand this well. And then you transition to the exam, which is like true or false, and asking you super pedantic kind of goofy things that don't really test your understanding of these complicated, multifaceted algorithms, right? So I just thought the exams were like superfluous, but they definitely did not stress the content enough to make them worth it, in my opinion. Like they were just hard enough to make it a pain in the ass, but not hard enough to actually reinforce the material. So to me, I would honestly just scrap them and add something else really cool, but like, I don't know, something with neural networks, reinforcement learning or whatever. But yeah, I just feel like the exams were kind of not really necessary and kind of distracted from what was otherwise a fantastic experience of going through and implementing these things as part of the projects. That's number one. Speaking of projects, I'm going to talk about the search project. So if you've been watching the vlog, I released one that was like a super rant about how the search project went. I'm definitely partially just coping here because I did not do well on the search project, but I do have some complaints about how it was organized. I think like the rest of them have a really natural progression of implement the thing yourself and then use it to accomplish something else, right? So like just as a random example, particle filters, you were doing something orbital. So you had like a satellite and you were trying to figure out where the satellite is based on measurements of other like planetary bodies. And so that's part A of the project. Then in part B, you take that estimation and you try to shoot a laser from your satellite at like an alien spaceship or something. So you're doing some like additional geometry on top of your estimation to try to connect those dots. And so I thought that was really cool and just shows how it would be used in the real world. I think a much better example here was SLAM, where you're building up a map in part A, and then in part B, you're actually doing pathfinding in the map that you built. That was super freaking cool. But the search project effectively has parts A, B, and C, all of which are like super disjoint from one another. This is like definitely my own fault, but I didn't really realize how one led into the next. And so I wound up just doing a bunch of redundant work. Like I said, that was my fault. I should have had more foresight in the beginning, but at the end of the day, that wasn't really required for all of these, like the rest of them. The rest of them was simple. Part A is do the thing. Part B is do something additional after you've implemented it. And the search project kind of just completely diverged from that format. So, it is what it is. If I sound a little butthurt, it's because I am. It's whatever. I just would change how that search project is done because I have literally done like A-star projects as part of my portfolio before. And I just kind of kept it simple and it really reinforced the concept. And another reason that I'm a little butthurt about this is because I understand these algorithms really, really well. And yet the project I just think kind of was a giant pain that I didn't wind up completing as well as I'd like. So that's the search project. That's kind of my second bad thing. And now let's talk about the ugly. So ironically, I think like the worst, maybe not the worst, but the area of this course that could be improved the most was the lectures. So no disrespect to the professor who recorded the original lectures, but they are very, very old. They are very, very outdated. And so like it's outdated. The material is like super, super high level to the point that like they literally left out a big chunk of the math for the different algorithms that we're doing. You would kind of just like scribble on the whiteboard in general what these concepts were about, and then basically give you spaghetti code afterwards. That did implement the thing. I mean, the code worked. That's no question. But it wasn't really well architected code. And some non-trivial percentage of the project was just translating that garbage into actual code that you can use in real projects. And that was a little frustrating. It was especially frustrating in this context where the lectures were so high level that it almost felt like patronizing at times. I think there's some history here where it was originally a Udacity course and you're trying to make it approachable as part of these like online certifications. I completely get all that. That's important context to have. But at the end of the day, this is a master's program, and you should be expected to do some freaking math in your computer science program. And so, like, the instructors and TAs did a really fantastic job of supplementing these super high-level, vague lectures with additional material, like tutorials and research papers, and all the other things that would be characteristic of a master's level course in computer science. Honestly, I just think the lectures kind of didn't really help that much. I think, to be honest with you, I would watch the lectures once. I would take some notes. I would go through all the instructor and TA's resources, which were usually much more helpful in terms of actually like solidifying the concepts in my brain. And then I would go implement them in these projects, really hammered it home. The lectures really didn't do anything substantial beyond just kind of starting the conversation, which is disappointing. So I would say my biggest recommendation to any instructors who may or may not be watching this, please don't fail me, is I would redo the lectures. Not because they're awful, like they're not really awful. They're just not at the level of quality that everything else that y'all put so much work into running really well is, right? And so if you redo these lectures, you modernize them, you have the code be like better formatted and actually have like files that I could look at instead of having to sift through videos on Canvas. Like if you fix these little quality of life things, I think it'll pay off so much more and really enhance the already great experience that you're giving your students. So that's my piece of advice. I also understand like the lecturer is a pretty famous guy, seemed very knowledgeable and definitely a good person to learn from. As a matter of fact, I would go and I would read his textbook, which didn't spare any of these ugly details, right? I just wish the lectures kind of included them more as we went through. So yeah, that's my major kind of change I would make is I would definitely say search project borders between bad and ugly. I think that also could use some work, but that and the lectures. So now let's get into my final review. What would I give it out of 10? I'm not going to beat around the bush. I can't write. I would give it like an 8.5 out of 10. I really thought it was great. I'm super glad I took this class as my first one. I think I'm very confident that there will be a couple of classes which are better than this one and a hell of a lot that are worse. I think it's a really great job. Awesome first course to take if you're just starting the program and you're interested in this stuff. I would really, really recommend getting started with it. Yeah, the topics were super interesting and I think really real world applicable. And yeah, I like the course overall. So that's my review. 8.5 out of 10, pretty positive rating. We'll see how the rating inflation goes as it goes through the course, goes through the degree. These are all the topics we went through, as well as some additional peripheral ones that you can find in the lectures or online, in the vlog episodes or online if you're really interested. But these are the broad strokes. These are the broad strokes of my review about the course, some of the things I thought they did best, some areas of improvement, and one kind of major flaw I think could be changed. But yeah, overall, really loved it. Thank you so much for sticking with me on this journey of my first class of this grad school vlog. I will continue to do it. And so yeah, I'm super stoked to get ready with semester 2, summer 2025. If you've enjoyed this content thus far, please continue to watch. I hope it's valuable to you, whether you're in the program or not. Like I said in the beginning of the video, I'm the Unhinged Engineer. I'm vlogging my grad school journey as well as making professional development content for young engineers like me. If that's something you're interested in, please like, comment, and subscribe. Thank you so much for watching, and I will see you next time.